Hey everyone, thanks for tuning in. I want to make a quick video about spoil boards. But I always use a sacrificial board. This is a 24 by 24 half-inch MDF that you can get at your big box stores. The bit we're going to use today is a Magnate, inch and a quarter flat bottom bit. I'm not going to link this bit because I've owned it for 3.5 years. Now when I first bought it, I paid like $12 for this thing. And it has been a great tool. But now it's like $25 and you can find them things so much cheaper on Amazon now. So, but anyhow, that is the bit we're going to use. Let's get started. We're going to use Carbide Create for software today. Okay, here we are in Carbide Create. First thing we want to do is go under settings. And what we do here is we set up our stock size, right? So my sacrificial board is 24 by 24 and it's a half-inch thick. Carbide Create now wants to know where we're going to reference our Z height from, where we're going to touch off our bit, to the top or the bottom of the material. And in this case, we're going to do the top. Excuse me. Toolpath 0. Now, not where does your machine home, but where is X, Y, 0 for this particular job? And these are your options. 90% of the time I go with center, unless my stock is already the size that I need it to be. And then you've got to do a little more work. But if you do center and the piece is going to be cut out anyhow, then it works every time. Material wants to know what kind of material. It doesn't need to know for anything, I don't believe. Down here, machine. In the drop down menu, they just want to know what kind of machine you have. I have the XXL. Retract height, we'll keep it set at the half-inch for now. That's a nice safe place to be. And then it wants to know what units you want to work in. I'm in the States here and I work in inches. Rarely do I do millimeters, but if millimeters is what you're used to, that's what we want to click on. Click OK. Now our job parameters have been set up. Now we just got to get into drawing what we want. And what I want is a rectangle. So we'll come over here, click on the rectangle tool. The center of my rectangle I want in the center of my board anyhow. So click once, release, and drag out the mouse. So just pick a random point, because click it again and this little window will pop up and allow us to dimension our piece. Now my stock is 24 inch by 24 inch, but I only want a 21 inch by 21 inch pocket cut out of it, because you can see here I have screws holding this piece down. I don't want to machine into it. And 21 inch by 21 inch is big enough for what I need it for. Now you also have the options in Carbide Create to either have square corners, add a fillet to your corners, a chamfer, a flipped fillet which rounds the corner inside, a dog bone which is for like a mortise and tenon deal, and a T. Again, today we only need it for square, to be square. This is where you can move, flip, offset your pieces. We don't need any of that, and we don't need to edit any nodes. So we just go ahead and hit apply, and Carbide Create has created our 21 inch by 21 inch square. And the only thing left to do now, which is a big thing, is a toolpath. Now when you click on toolpath, Carbide Create gives you 3 options right away: a contour, a V-carve, and a texture. Now what we want today is a contour, and when you click on contour, a whole nother sub window, if you will, opens up. And the first thing that we see is our tool. It wants to know what tool we want to use for this job. Now it defaults to an 1/8 inch tool number 102. Well, that's not going to work. That would take us all day. So click on Edit, and your tool library will come up along with your cutting parameters, speeds, and feeds. Now to change the tool, click on this drop-down menu right here. Now, my tool, I already added, because like I said, I don't use Carbide Create very much, and I wanted to be able to make sure that I wanted to familiarize myself with it. So I've already added mine. Mine is the 1¼ inch flat bottom bit that I showed you. Your tool probably won't be in here neither, so we'll go ahead and show you how to add a tool to the library. Now the first thing you want to do is click on Edit Library. This pop-up window will come up. Come down to Add a Tool. And what Carbide Create does is it always defaults, I don't know why, to an 1/8 inch end mill and then adds a number to it, consecutive number. What we need to do is right click on that tool that they add, click Edit Tool, and sometimes the edit window will change and this will go away. If it doesn't, you have to left click on it after hitting Edit Tool, and it will get to where we can modify it. You have 3 choices here for end mills: flat end mill, a ball mill, or a V mill. Ball mill is usually for 3D working or bowl work, and V bit is for V carving. We just want a flat end mill. Description, we'll call this wasteboard. And I don't know if wasteboard is 1 or 2 words. Today it's 1 though. Wasteboard bit. How's that? Tool number, we'll keep it the same at 19. Tool diameter is 1¼ inches. Flute length. Now I've owned that bit for 3.5 years and I don't remember what the flute length is. I can measure it right now, but it's not critical for this operation. Now when you order your new end mills, they will come packaged with all this information on the package, or bare minimum on the supplier's website. They will tell you the cutting diameter, the flute length, angle per side for your V bits. That's usually only for V bits, and it will tell you how many flutes. This one is 2 flutes, and then you have to tell Carbide whether it's in inches or millimeters. This is very important. If you take what you think is a 1/4 inch end mill and it ends up being a 6 millimeter end mill, your piece will be too small. I'm sorry, be too large, because 6 millimeters is smaller than a 1/4 inch. Anyhow, so this is an inch bit. Click OK. The tool's been updated down here. All we got to do is X out of it. Go to our drop-down library, come down to the bottom, and there's the tool we just added. Now the other thing Carbide Create does that I don't like, and you've got to undo it too, it never works out, is it sets speeds automatically. It sets speeds and feeds automatically for the tool based on the parameters that we told it, diameter, things of that nature. So you have to unclick that to be able to modify all this. Depth per pass, that is how deep that bit will cut each time before it plunges down again for another depth. We're going to go 0.1 or 1/100,000ths of an inch per pass for that bit. May seem like a lot for such a big bit. We're only cutting into MDF. It will do it without a problem. Step over for a pocket is, you normally want to stay around 40-42% unless you're doing 3D work, and then you use a finer step over. But in this case, we'll keep it at the 0.563. Spindle speed. See, this is what I'm talking about. Like, it set this automatically to 2445. That's 2,445 RPMs. No router even goes that slow. My spindle that I have, I can't even run that slow. That's for a true milling machine. So I'm going to go with 18,000 today, because if you're here with a DeWalt, that's as slow as you go. That's what setting number 1 gets you, is 18,000 RPMs. It's a little fast for such a big bit, But I've run into that before, and we're fine. Just make sure it's tightened down and you call it good. Feed rate. At 4.8, you would it would take us probably hours to do this. 80 inches per minute, right? I know. If you're new, it seems fast. Trust me, your machine will handle it. So long as you keep that tight and you call it, all will be well. If it bothers you that much, you can drop it down and be more conservative to, say, 40 or 50 inches per minute. I don't recommend dropping it any lower than that, particularly when you have such a fast RPM, a high RPM. Otherwise, it throws your feeds and speeds all off. Plunge rate, 30 inches. Again, that may seem fast, but we're only talking MDF. And the other thing here, let's click OK, because we've set all our parameters. We like the way it looks. Click OK. And you'll see here that our tool's been updated to the one we want instead of the 1/8 inch bit. Now this happens a lot with Carbide Create. If you see here, it says step over is 0.056. Well, that's not what we wanted, and that's not what we typed in. If you look here, you see that it's correct into what we want. Sometimes you got to go back and click OK again, and you see it's updated. Feed rate's good, plunge rate's good, and our RPM. So our tool is all set. The next thing Carbide Create wants to know is our cutting depths. Where we want to start. Now we want to start at the top of our board, which is our 0 for Z. Right? So start depth 0. Max depth. Max depth for Carbide Create is how deep do we want this pocket. And in this case, I don't want it very deep. It doesn't need to be very deep. I'm just trying to flatten it out. So 0.070 or 70 thousandths of an inch. Now that should be plenty to flatten my board and make it parallel to my spindle. And if it's not, I'll have to come in here and we'll have to adjust it, make it deeper. But you know, I've run this before, and so I'm pretty confident that that's going to be good. The next thing is the offset. They call it the offset direction. And what that is it wants to know what kind of toolpath we want. Do we want a pocket, which just so happens is what we want. That way, it'll take our square, come in the inside, start in the middle, and work its way out, cutting the inside out to a depth of 0.07. We can name the toolpath if we want. Waste. I'm just going to call it, keep it simple, click OK. So you see now our toolpath has been generated. It's been named what we give it, and it gives us a time, which is pretty accurate. I was pretty surprised. They do a good job at estimating the time. It's telling us it's going to take 12 minutes. This is where I said with that step over, if we didn't catch that, it didn't update that step over, or if we used Carbide's original 5 inches per minute, this thing would have taken us like 2 hours. So it's going to take us 12 minutes. That's fantastic. So we're done here. We could save our G code, send it off, and run the part, which is what we're going to do. But you can also do a simulation. Now I'm going to warn you up front, anyone with a heart condition, it's pulse pounding. There it is. Yes, I know. A little save G code. That's where we're at. We're going to save the G code. Pick up Carbide motion. That's what I use to control my machine. Okay, here we are in Carbide motion. My machine's turned on. We need to connect to cutter. We're now connected. I have homing switches on my machine. If you don't, you should get them. I don't know what else to tell you. You should not have a machine without homing switches. Click continue, the machine will home. Now we need to set up our X and Y 0, like we told Carbide Create we would, and where we told them we would. And we told them we would set X, Y 0 to the center of our material. Now I've already set it to do. is we need to set the Z height to the top of our workpiece. All right, because again, that's where we told Carbide Create it would be. So we'll bring this down. And we bring out our probe. Just like Holman switches, if you don't have a probe, I recommend you get one. Click begin probing. Now when you probe with the machine, you got to make sure the bit is within, I believe, like a 1/2 inch or somewhere around that. Otherwise, it will time out when it's going down looking for the probe. If it doesn't hit it within a certain distance, it will error out and you'll have to rehome the machine and start all over again. Okay, so we've zeroed out the machine, both X, Y, and Z. The next thing we have to do is install our bit. And to do that, we're going to wrap it to the front of the machine. Take our wrenches. I have to change my collet out and everything because I have a 1/8 inch collet in here. My bit's 1/4 inch shank. Real simple to do. Alright, so our bit is installed. We go back to current XYZ offset. Now, for anyone paying attention, you will notice that I made a mistake. One you want to make sure you don't make. I have already set my Z0 butt to my 1/8 inch drill bit. Alright? Well, that's not going to work because this bit is at a different location. Long story short, I messed up and we have to reprobe for Z height. That's all right, it's fun to watch. Comes down, touches off. We're ready to load the new project. We have 109 lines. That seems a little light. Go back into MDI. I'm actually going to put that at 18,000. Get it spinning. Well, that gets up to speed. Now my spindle is a 2.2 kilowatt spindle, water cooled, heavy, like 12 pounds, but it's worked well. All right, we're up to speed. I'm gonna let it start cutting without the vacuum so you can listen to it for a bit, but when it starts building up the dust, I'm gonna have to turn the vacuum on and may get a little louder in here. All right, go to run. Click start. Now Carbide Create puts in this little tool change command. We've already done that. Just click continue. And we're off. Now you can hear at a depth of 70 thousandths and a feed rate of 80 inches per minute, it's not even breaking a sweat. And actually I'm going to increase the feed rate by 100%. Now I have linear rails on my X-axis and an upgraded Z-axis, but you can hear that's running fine at 160 inches per minute. So I got to turn the vacuum on now. it didn't take very long at all. Again, I doubled the feed rate override. So I think that was what, maybe 5 minutes tops. And now we have a perfectly surfaced spoil board ready for V-carving. Thanks for watching. Stay tuned.